In this last demo, we're going to learn how to use the CTL to load and also write into multiple NetCDF files, and also to do more complex operation like extracting only portion of the output from the model. So in this particular case, just to show you the power, I'm using the CTL array that has 184 files. Okay, so it's a very big file, and in particular I'm going to begin by looking at a particular point in space. So, for example, suppose that I'm going to make a plot now of my grid using RNT PLC grd.h, grd. Actually, let me plot the what were we plotting before, the zeta. Let me see if I have zeta here. Okay, so I can plot RNT PLC zeta, grd. So I'm going to plot the free surface height. Okay, so this is the free surface height. And now I'm interested in looking at a time series, say at this particular point over here. Okay, so how can I do that? First I need to locate that point. And to locate that point, I'm going to use this command rgrd find point in the grid grd and 1 point. Okay. So I'm going to do that, and then I can go with the mouse here and select, for example, the point. Actually, I want to select the point here. Okay. So now that will actually find the I and j locations in the grid of that point. So now I want to load the entire sea surface height, for that point, and in particular all the Januaries. So again, I'm going to find the Januaries in my CTL, and then I'm going to say zeta equals. I'm not going to load the mean anymore, but I'm going to load. So here I could load the entire sea surface height now, right? As we did before by using CTL in zeta. This will load the entire zeta. But I only want just this particular point. So what can I do? Well, I can expand this call and put an I and a j, which is the location, and then also the level that I want to extract. In this case, the sea surface is only one level, so I put 1. And then I'm going to modify slightly the rnt load var command to be rnt load var seg p. Okay, so now I execute this, and if I do a size of zeta, you'll find that now you've actually loaded the entire January month. So I can do a CLF and I can plot zeta, and now I have a time series of all the January months of the model. Now suppose that this run in particular, if I look at the CTL, is actually an hindcast run from 1950 to present, but it actually has 3 consecutive hindcasts for the same periods, and these are labeled by this other additional field that is in the CTL, which is cycle, and so you can see actually it has 4 cycles. So suppose that now I want to load all the output of cycle 2. Okay, so I do that. Then I can load a time series now for cycle 2. So now this would be a cycle, I believe it's about 54 years. And I can plot, for example, the output of one of the realizations, and it has a slightly different structure. In this case, I can actually plot also, I can use the CTL date num that I have here for that particular cycle. And then I can use the date thick command, and now I get basically a time-dependent time series at that particular point. Now what if instead I wanted to plot, sorry, I have to reload, let me just plot the topography at this point so I can have a grid, a map of the grid. Okay, so this is topography. Now suppose that I wanted to just have a particular area, say this, a subset of indices that is located in this region of the sea surface. Say the velocity field, and I wanted to grab the third layer. Well, what I could say, suppose I want the u velocity, I can do rnt load var underscore seg p. Okay, and then I'm going to say I'm going to load from the CTL. I'm going to load, for example, record, say 3,000. No, say 250. Just any record or a whole bunch of records that you want. I'm going to load the variable u, and now I'm going to load you know, the entire I could load a range of indices in the I and j. In this case, let's say I want to load from 100 to say 150 in the I range, and the j range I want to say load 40 to 100. Okay, and I want to load level number 5. Okay, for example, or actually let's take the surface, which would be grd.n. Right, it's the last element in the surface direction. And so I do that, and now I have this U array, and I can actually plot it. I can do pcolor grd.lonr. In this case, I have these ranges here, which is these ranges for the longitudes, and also grd.latr, same ranges for that. And then I have my U array. So I can do that. And this now I can do, well, actually, this is fine enough. And so now I've plotted just a section of the U velocity field that is, is encompassed by these latitudes and these longitudes. Okay, so I just subtracted a certain portion of the whole field. Okay, so that's kind of nice. So the two commands then that I can use are, one, the RNT load segp. The syntax is the CTL array, the indices that you want to load. So this could be actually a range. Suppose I want to load from 200 to 250 per se. Then you have the name of the variable, and you can, if you don't know that, you can do an NC-dump to see the name of the variables. Then a range of I indices, a range of j indices, and a range of indices for the vertical layers. And you can also choose, for example, to pick the entire three-dimensional structure. But let's take the surface, and so this is, for example, now loading 50 records, and you can see now size of U. It has dimensions of x, y, and then the 51 records that I loaded. Okay, so this is load segp, or if you want to load, for example, just the entire value of a variable. For example, say you want to load record 450 of the free surface. Okay, so you can do it this way. Now, what is, suppose that now you have this free surface and you want to create, oops, let's stop this, and you want to create a new file with an initial condition file that has the free surface at this particular value. Okay, so now you have the free surface. Okay, so if I want to create an initial condition file, well, what I can do is I can use some very fancy routines. I can, here this is in your, I am editing this file here, which is main.netcdf file, which contains the tutorials. Okay, so suppose that you want to create a file, say that contains an initial condition and is extracted from record 11 of your output of your model output. So I can create a new name. Then I'm going to say index 11. Then I'm going to create a netcdf file where I'm going to store this initial condition. And to do that, I'm going to use again the rnc create ini file that has a grd as an input. This is the grid that we're using, in this case the NEPD grid. So let's actually load it. grd equals rnt grid load of NEPD. Okay, so we put it there. And then the file name, which we've already assigned. And then it has an additional argument, which I call opt, stands for option. And this argument is, again, is a structured array, and it has two fields: time, which is basically says the number of time records that you're going to store, and then time val, which is the value of the time for those records. So you store, the value of the initial condition. Time is in second in this particular case. So what I'm going to do that is the length of index is going to be 1, because index is only 1. Of course, you could have more than you may want to store more than one record, but in this case we're only going to store 1. And the ctl.time of that index is going to have the time value. And so now I can just pick up this whole thing here, go here and just paste it. And if I do an ls minus rtla, I find that I created now an empty initial condition file. Okay, and I can do a more on this file here. Sorry, an NC-dump on this file to see in fact that this is the case. And so here I have now an initial condition for the model, and with one time record. And if you go down, these will all be 0. Now, how do I write in this file? Well, first I'm going to extract the free surface, which is record 11, like that. Okay. Then I'm going to create another CTL array for the initial condition file. So the initial condition file is going to be rnt times CTL. Then I'm going to open the graph, put the name of the initial condition file, F12. Then I'm going to close this, and I'm going to say that the time variable in this file is ocean time. Okay. So now I have two CTLs, one of the output and one for the initial condition. And in this case, the initial condition has only one file and so forth. So now I want to store my free surface height, this one, into the initial condition record in this file over here. So how do I do that? Well, I can use this command, save var of CTLi, so in which CTL you want to go. Then we're going to say which field we want to store. And actually, we're going to say in which record we want to store. Let me actually look at the syntax again, because I also forget sometimes. So we do save var, and so this is the syntax. Okay. And so we have CTL, the index where we want to store. In this case, it's the first one of the initial condition, the CTLi. The field that we are storing in is the free surface height. And the field values are the one that we loaded, which are contained in zeta. Okay. Oops. Sorry, I just pressed the wrong button here. So it's zeta. The variable is called zeta. The index is going to be number 1, and the CTL is now the CTLi, which is for the initial condition. So I can press return. And so now it says that it's basically stored zeta in this file here. The source index for zeta was 1 to 1, and the destination index was this, this particular one, which is index 1. So this is really a way to save, a file using the CTL interface. Now the nice thing is that if I wanted to, for example, to save this zeta into a record of the whole full run, say this particular run, and I wanted to save it at record, say 2100, the last record, I wanted to modify that, I could have done something like this: rnt save var. Then I would put the name of the record there, say 3, 4, 5, whatever record you want, and then if I enter now this command, this would actually locate the time record 345 in this whole concatenation of files. It will locate which file contains that. It will open that record and store the free surface in that record. So you would actually not even know which file is writing in, but you would rely on the CTL interface. So this is kind of very powerful. But of course, you can also use this kind of interface to just write in a simple file like we did in this case over here. Now this particular example is also in the tutorial here, and you'll find it in tutorial number 4. Okay, so this is it for this group of tutorials on NetCDF files.